Hi guys, welcome to this page in the notes. What we're going to do here is we sort of wrap up this chapter on trigonometric functions, and we're going to take a look at solving some problems using the trig functions we've already looked at, sine, cosine, and tangent, as well as solving some area problems. So here we go. First, our essential question: how can I solve a right triangle, right? How can I find the unknown measures, whether they be lengths or angle measures of a right triangle? And to the rescue come the trig functions. Sine, cosine, and tangent will help us find those unknown measures. Now, some objectives, learning targets as we go through this. First, we're going to use these trig ratios to find the area of a triangle, and then we're going to go ahead and solve some problems finding those unknown lengths or angle measures given some problems, whether it be a diagram or a word problem, whatever it is. Sine, cosine, and tangent to the rescue. They'll help us solve those problems. First, let's start with area. So we can use the sine, cosine, and tangent to help us find the area of a triangle. And here's the way it's going to work. You should remember from earlier in the year we looked at the area formula, and the area of a triangle is 1/2 base times the height. Base times height, right? 1/2 base times height. Well, I take a look at the triangle that I've been given, right? And I know a couple of things. First, the height would be right here. I drop a line from the vertical from this vertex to the hypotenuse, which I've done in this diagram over here. We'll get to in a second. So that'll be my height, which I don't know. But in this diagram, that means that this guy down here, A, is my base. So let me plug that in. In this diagram, this guy right here is the base. So I will have area is equal to 1/2 A times the height. Actually here, you know what? It looks confusing because I'm switching variables, and that triangle has a B in it as well. It'll be much better if I write it like this. So the area is equal to 1/2 the base times the height. There we go. That'll make more sense. Okay, so in my triangle, what is my base? Well, in this triangle, the base would be A. So the area is equal to 1/2 A times the height. Fantastic. Okay, so now the only other thing I need to figure out is what is the height. And this is where the trig functions help us. Take a look at this. In this triangle right over here, if I were to go ahead and take angle C, and again, it doesn't matter which angle, angle C, angle B, angle A, I'm just picking angle C for now, so stick with me for a second. If I do sine of angle C, I know sine is the opposite over the hypotenuse. So the sine of angle C is going to be equal to, well, if this is angle C, right, here's my right triangle. In fact, let me draw your little right triangle in green. There he is right there. There's my right triangle. All right, angle C, what is the opposite side? Well, the opposite side is H. The hypotenuse is B. So I have H over B. And I'm trying to figure out what is the height. So we'll multiply the B to the other side. We get H-E-I-G-H-T. The height is equal to B times the sine of angle C. Right, all I did was solve for H. Well, substitute. I'm going to plug this guy in right over here. And here's what I wind up with. I wind up with the area is equal to 1/2 A times, well, what is the height? B times sine of C. And finally, area is equal to 1/2. I don't need the parentheses anymore. A times B times the sine of angle C. And what we've got is you have an area formula, a way of calculating the area based on our trig functions. And I know you're thinking to yourself, holy cow, that is ridiculously complicated. Yes, except in practice, when actually solving a problem, it's much, much easier than that. So here's what we're going to do. I have right down here, right, I've given you all of those formulas. Say, hold up a second, whoa, 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 why are there three? We only found, well, that's because I only showed you how to find one of them. Remember, I said it doesn't matter whether you use angle C, angle B, or angle A. Sine of A, sine of B, sine of C, right? It doesn't matter which one you use, you can find the area of the triangle using any one of them. Okay, I just showed you how to find this one, the sine of C, this guy. Okay, whatever, no big deal. Here's how this is going to work. When you are solving these problems, what you are simply going to do, whichever angle you choose, whichever angle you are given, use the sides adjacent to the angle. And I know you're thinking, wait, how does that help any? Well, here's what you're going to do, right? Rather than trying to remember or trying to write those three formulas, which is not necessary, I won't ask you to derive them on a test. I'm not going to do that. Here's the way it's going to work. I will give you a triangle. I have to give you a couple of things. I have to give you an angle, and I have to give you two of the sides of the triangle. So, in order to solve these problems, what you're going to do is you will simply use area is equal to 1/2, right? Whatever the two sides are that are adjacent to the angle, right? So A times B. Whatever those two sides are, one goes here, the other one goes here, and then you'll take the sine of whatever the angle is that you're given, right? So whatever the angle is and the two sides that are adjacent to it, just plug that stuff right into this guy. Don't fat finger something on your calculator and you're all set. Head on over to the next page in the notes. I'll show you how it actually works. It's a lot simpler than what it seems. You'll catch on real quick as we do a couple of problems, and I'll meet you there.